Okay, dear students, how are you all? So today I just have brought one final exam for you. It's an applied mathematics 1B final exam. Now I'm going to show you how you can solve some all questions available in this final exam. So I would like to recommend you to subscribe this channel because the channel is containing a lot of tutorials for different applied mathematics courses. Now, when I directly go to this final exam, look, as you see, the final exam is given 3 hours to be done, and there are 7 multiple choices, 8 fill in the blank space questions, and 4 workout questions. So I'm now going to show you how you can solve all these questions. So let's directly go to see how the final exam looks like. So as can be shown, 7 different kinds of multiple questions are available here, and there are also 8 different kinds of in the blank questions again, and 4 different workout parts are also available, as you see. So I'm going to do all this for you because I strongly believe that this will help you in order to be fruitful in your study or in your course. So here I directly go to the first question. So it says find the angle between the vectors u10 minus 1 and v110. As you studied, students, the angle between two vectors can be obtained by using this formula, which is cos inverse of the dot product of the two vectors divided by the product of the two norms. So here, as can be shown, the vectors must be non-zero in order to have a meaningful output here. So we need to first find the dot product of the two, and next we need to determine the norm of these two vectors. Okay, so the dot product of the two can be obtained in this manner, as you studied. 1 times 1 makes 1, you see, and 0 times 1 makes 0, and negative 1 times 0 makes 0, so the sum comes 1. So as you see, the dot product is now determined, the numerator is now known, so we need to determine the denominators. So the norm of u has to be calculated, and it is calculated as the square root of the sum of the square of the components, as you see. And here 1 squared, 0 squared, and minus 1 squared must be considered. So this makes radical 2. Similarly, the norm of v must be calculated, and the norm of v is calculated by the square root of the sum of the squares of the components, which actually is 1 squared plus 1 squared plus 0 squared, which actually is again radical 2. Now, dear students, u dot v is already obtained, their norms are already obtained, so next task is a matter of substituting. So look, cos inverse of u dot v is already 1, and the norms are radical 2 and radical 2 again. So this makes 1 over radical 2 times radical 2 is 2. So cos inverse of 1 over 2 can come. And you need to think of an angle, a special angle, whose cosine makes 1 over 2. And as you know that it is 60 degree, and the equivalent radian for 60 degrees pi over 3. So the answer for this is going to be B. As it is stated here, it is B. So the first is now solved, and going to the second one, you are asked to find the limit of this function or expression. So how are you going to find this? So simple. What you need to do is you must have a certain simplification thing here, and that is, look here, the minus sign is used, so you need to multiply by the plus of this expression for here, as you see. Doing this never changes the given expression, because we are multiplying the numerator and the denominator by the same expression as can be shown. But in doing this, we can change the non, you see, evaluated expression, the non to be evaluated expression to, you see, some expression that can easily be evaluated by its limit. So this is going to be like this now. Look, you can consider this as A, and you can consider this one as B. A minus B is appearing here. So this is A plus B. So A minus B times A plus B is going to be A squared minus B squared. So when you remove this radical expression, you do have x squared plus 1 plus x as it is. This is your x squared, right? And minus, look, x times x makes x squared. The one you said b squared comes. Then here you are having 1 as a denominator, so 1 times this is the expression itself, as can be shown. Now from this, you see you can now simplify x squared by x squared, and then 1 plus x comes, and the square root of x squared plus 1 plus x follows. Now look here, student, that the numerator is having degree 1, so here also we are having degree 1, even though degree 2 looks the degree of the denominator is not like that because it's under radical. So we need to multiply both the numerator and the denominator by 1 over x to put the expression in such a way that it can easily be analyzed. So as you are multiplying both by 1 over x, look, 1 over x times 1 makes 1 over x, and this is plus 1 because x times 1 over x makes 1. So look, 1 over x, as you are multiplying to this, it can be, you see, inserted inside this radical expression by taking 1 over x squared, right? 1 over x squared, 1 over x squared, 1 over x squared. So as you are multiplying x squared by 1 over x squared, it will be 1. And here you do have 1 over x squared plus 1 over x can come. And here x times 1 over x is 1. So as you see, the expression looks like this. So further simplification of this makes like this, as you see, 1 plus 1 over x. Now here 1 can come plus 1 over x squared. This is 1 over x, and this is 1. So as x goes to infinity, this is approaching to 0, and this is again getting closer to 0 at a faster rate because it's 1 over x squared. This is 0 again, and this is 1. So 1 over, you see, this makes 2 because 0, 0, 0 plus 0 is 0, 0 and 1 makes 1, radical 1 is 1, 1 plus 1 makes 2, so 1 over 2 can come, which actually is 0.5, right? So the numerator makes 1, the denominator makes 2, so 1 over 2 is 0.5. So this is available here in C, so you can make your choice to be C. Now proceeding to the next one, question number 3 says, which one of the following is true about this function f? And it's talking about critical number, as you see. And how do you define a critical number, students? A critical number is a number in the domain of the function where the derivative of the function at that particular critical number is either 0 or doesn't exist. And what you need to know in another point is, you see, critical number, as the name implies to you, is a critical one. Because if your function is having local extreme values, the critical number is a place where you can detect these local extreme values, either local max or local mean. But it doesn't mean that at every critical number we do have always these local extreme values, okay? Having this into account, when you come to the solution of this one, this is a definition I told you earlier. So a critical number is a number in the domain of the function where either the derivative is 0 or the derivative doesn't exist. So if a function has a relative extreme value, it occurs at the critical number, look. But it doesn't mean that always at the critical number there always exist what? Extreme values. As you see, having a critical number doesn't give a guarantee for existence of extreme value at the critical number. So if you see B says if C is a critical number of f, then f of C is a local extreme value. No. There are cases where you don't have this kind of condition. For example, take f of x equals x cubed. The critical value here is 0 because the derivative of f with respect to x is 3x squared, and 3x squared is 0 at 0. So even though 0 is a critical one, we don't have relative extreme value at 0. Right? So the answer for this is going to be B, because B is false. But if you see the others, you see the first one, the definition basically, and when you come to the third one, look, the third one is again the reason why we are talking about the critical number. If f has local extreme value, it occurs at the critical number. It is true. It occurs at a place where either the derivative is different from 0, or I mean the derivative is 0 or the derivative doesn't exist. So the answer for this is going to be B. So as you see, it is B. And proceeding to the next one, we have question number 4, and you have been told that a certain function is given, and the integral from 0 to 10 of that is 17, and the integral from 0 to 8 of that function is 12. So the question is to find the integral from a to 10 of this function, assuming that the function is integrable or continuous within the interval 0 to 10. So as you know, if the function is continuous on the interval 0 to 10, then the integral from 0 to 8 of the function plus the integral from 8 to 10 of the function must be the same as the integral from 0 to 10 of the function. This is one property of the integration. As long as the intervals are not overlapping, we can have this kind of condition. Now, from this, you are asked to determine this value. You see the integral from 8 to 10 of f of x dx. So in order to know what this is, you need to shift this expression to the right. And this turns to be like this. You see, 0 to 10 f of x dx minus 0 to 8 f of x dx. So from this, the value of this is already determined. It has been said that this is 17. Look, here it is. Directly we put 17 here, and this value is also determined, and it is 12. So we are having now 17 minus 12 as the value for this one. So clearly this is going to be number 5. So the answer for this is going to be C. I hope you have understood how we can find solution of these 4 questions, right? Okay, dear students, now let's continue. Now coming, the one is the 5th question, and it says the equation of a plane containing the point 1, 2, minus 2 and perpendicular to the line L, x minus 1 over 2 equals y plus 4 over 3 equals z minus 2. So here you are asked to find the equation of the plane, and the symmetric equation of the line is given, and one point lying on the plane is also given, 1, 2, minus 2. So how can you determine now the equation of the plane? Dear students, you need to know here one thing. If you see the denominators here, look, in the first case 2, the second one 3, and the third one 1, even though it's not written, it's understood. See, these numbers 2, 3, and 1 represent the components of a vector, directing vector of this line, okay? So the line is supposed to be parallel to the vector having components 2, 3, 1. So here, if the line is perpendicular to the plane, or if the plane is perpendicular to the line, as long as the directing vector is parallel to the line, again the directing vector is going to be perpendicular to the plane. So what you need to do here is, you see the directing vector, the vector with components 2, 3, 1 is considered to be the normal vector to the plane. So if you are given a normal vector to the plane and a point lying on the plane, it's very simple to determine the equation of the plane thereafter, because it's a matter of applying a times x minus x naught plus b times y minus y naught plus c times z minus z naught equals 0. Now you can consider ABC to be these numbers 2, 3, and 1, because these are, you see, components of the normal vector, whereas these points, this point 1, 2, minus 2, you see, is a point lying on the plane, so you can consider x naught to be 1, y naught to be 2, and z naught to be minus 2. So using this into account, you can directly go to what? The following one. So look, if the plane is perpendicular to the line, then the directing vector of the line with components 2, 3, 1 is normal to the plane. So from this, we are going to have this equation directly used from the obtained formula. Look, the components are of the vector are already written here. 2, 3, 1. Even though it's not written, there is 1 here. Then x minus 1, because you are going to use x minus x naught. Here your x naught is 1. Y minus y naught, because your y naught is 2 here. And z minus z naught, because your z naught is minus 2. And here z minus minus 2 is going to be z plus 2. If you see the coefficients 2, 3, 1, all are taken from the components of the directing vector. Now students, if you if you simplify this, you will finally come across with the equation of the plane. And this is 2x minus 2 plus 3y minus 6 plus z plus 2 equals 0. So try to add those numbers together, and then you can have 2x plus 3y plus z minus 6 equals 0. And I hope this is available in the given multiple choice item. This is -2 -6 -8 -8 plus 2 is -6. So, and moving this -6 to the right, you could have 2x plus 3y plus z is equal to 6. And this is available here in A, so the answer for this is going to be A. And having this into account, what comes next is question number 6. So when we go to question number 6, we are having this one. It says given an expression y, an equation y is equal to cot inverse of tan x cubed, then here you are asked to find the derivative of y with respect to x at x equals 0. So this is very simple. What you need to do is you need to recall the derivative of inverse function. And we know that the derivative of cot inverse is -1/1 plus x squared. And using chain rule, we can directly find the derivative of this one in a simple form as follows. Look here. The derivative of y with respect to x here is going to be the d by dx of cot inverse tan x cubed. So clearly, as can be shown, you're going to consider this as y because it's already given for you. Now what you need to do is you have to recall the derivative of cot inverse x. And in x you are going to use tan x cubed. So chain rule again must be used. So we know that the derivative of cot inverse x is -1/1 plus x squared. But in place of x squared, we need to put tan of x cubed because in x we do have tan x cubed. So tan squared x cubed can come, and then we need to derive tan here, and we know that the derivative of tan is x squared, and then x squared x cubed follows, and finally the inner one here x cubed must be derived, and when you derive this x cubed you do have 3x squared. So in general the derivative of y with respect to x makes this. No need of now simplifying this because you are not supposed to find the derivative of y with respect to x directly. Rather, you are asked to find the derivative of y with respect to x at x equals 0. So what you need to do is you need to substitute 0 in place of x. So as you are substituting 0 in place of x, look here, this is tan squared 0, this is 0, but 0 plus 1 makes 1. And here, even though 6 squared 0 makes 1, because of having x outside here, 0 squared is 0, 0 times 3 is 0, so everything goes 0. 0 divided by 1 is 0. So the answer for this particular question, that is, dy by dx at x0 is going to be 0. And this is available in D there. So the answer for this is going to be what? D. So having this into account, what comes next is question number 7. So question number 7 is the last, I think the last question in the case of multiple choice item. So you are given this one, the integral of ln x dx, but here it is a definite integral because the lower limit is 1 and the upper limit is e. So here we do have these multiple choices, so how are you going to find that? What you need to do is like this. First, you have to remember integration by part. It is using integration by part that you can solve this one. So let u to be ln x, student. Let u to be ln x and dv to be dx, as you see. So if u is ln x, the derivative of u with respect to x would be 1/x dx. And if dv is dx, then v comes to be x. So the integral of u dv is equal to uv minus integral of v du, as you know. This is integration by part. And from this one can obtain the following one. The integral of ln x dx is going to be, now you are having u times v, so your u is ln x and your v is x. So it will be x ln x minus the integral of v du, it says. So your v now is x, so you directly substitute that x here, and the du will be derivative of ln x, which actually is 1/x dx. So this makes the following: x is cancelled by x, then the integral of dx is going to come. So from this, the following can come: x ln x minus x. So had you been asked to find the integral alone, this could have been the final solution after having plus a certain constant c. But this is a definite integral, so it requires substitution of the lower and the upper limit integral values. So what we need to do is the following one. The integral from 1 to e of ln x dx now is going to be, first we need to substitute e in place of x throughout. Here e ln e minus e must be used because we are having, as you see, a definite integral. And then we have to have minus here because of the rule of, you see, fundamental theorem of calculus. So you do have minus. And then you put 1 in place of x here. It will be 1 ln 1 minus 1. So as it can be shown here, the integral from 1 to e of ln x dx is going to be now e ln e minus e. You simply put e here. Then have minus here, then 1 ln 1 minus 1 can come. And we know that ln e is logarithm of e to the base e. And this makes 1. So e times 1 is e, and e minus e makes 0. So this is going to be 0, students. And we know also that ln 1 is 0. Ln 1 is 0 because logarithm of 1 to the base e is 0. So 0 times 1 is 0 again. And 0 minus 1 is minus 1. So what you are having now is the following, students. So this is going to be this one. You see, this is e minus e because ln e is already 1. 1 times e is e. E minus e, as I told you, it is 0 minus. Here we are having ln 1, 0 again. 0 minus 1 is minus 1. So as you see, 0 minus minus 1 is going to be obtained. And this makes 1. So the answer for this is going to be C, because it is already written under item C. Okay, dear students, now comes the next part of this question, and it is instruction 2, and this is actually fill in the blank part. So I'm going to show you how you can also find solution of certain questions under this part. So the first question says find the unit vector parallel to the xy plane and orthogonal to the vector 2i minus 4j plus 2k. So the solution goes like this. What you need to do is first let you assume the unit vector to be ai plus bj. I'm just having here k component to be 0 because it has to be parallel to the xy plane. And for a vector to be parallel to the xy plane, the z component must be 0 because you must not have any sort of intersection between the vector and the plane. And for that sake, I just have omitted the k component. Hence, let u be ai plus bj and assume that this is a unit vector. And we know that the unit vector is a vector with magnitude 1. So from this, if the unit vector is orthogonal, then the dot product between this vector u and the given vector must make 0. This is a given vector. So you have been told that this vector is being a unit vector, it has to be also orthogonal. So the dot product necessarily must make 0. So here we are having, you see, the components a, b, 0. And here 2 minus 4, 2 directly taken from this one. So I'm having here 0 because the z component is 0. So from this, applying this dot product property, we can have this one, which actually is a times 2 is 2a, and b times minus 4 is minus 4b is equal to 0. And from this, students, a comes to be 2b because a matter of shifting this one to the right and dividing the whole by 2, you will obtain that to be a to a equals 2b. So from this you do have this information, and additional information is also noted here because this is a unit vector. So what you need to do is the sum of the square of these components must make 1. As you see, the sum of the square of these components must make 1 because it has been told that this is a unit vector, but we knew what a is. A is 2b, so we can directly substitute 2b here in place of a. And then we can have this to be, as you see, 2b is a whole squared plus b squared is equal to 1. Because in place of a I used 2b. Then 2b squared plus b squared makes 5b squared, as you know. 5b squared equals 1 can come, and b squared is going to be, b is going to be plus or minus of 1 over radical 5 can come. As you see, b is plus or minus of 1 over radical 5. But we knew what a is. A is 2 times b. So from this, a is going to be 2 times 1 over radical 5, which actually is plus or minus of 2 radical 5. So the value of a is now known, as well as the value of b also known. So the unit vector parallel to the xy plane being orthogonal to the given plane, orthogonal to the given vector, is going to be, we do have two options. One is 2 radical 5, 1 radical 5, and the other is minus 2 radical 5 and minus 1 radical 5. We do have two possible vectors for this. If you observe these two, you see they are unit vectors for one thing, and for the other thing, if you just take dot product between these two vectors and this one, you will obtain 0, and this shows you that these vectors are, you see, perpendicular, orthogonal to the given vector. So these are the options that we can have as solution for the first one. And proceeding to the second, we have another question here. You have been told that f of 2 is 3e squared and f at 0 is negative 5. The question is to find this integral. So beloved ones, what you need to do here is you need to recall integration by part, nothing else. So when we directly go to the solution, the integral from 0 to 2 of e to the power of minus x f of x dx. Using integration by part, let u to be f of x and dv to be e to the power of minus x. So as you are integrating this, you will obtain this one using integration by part. So what has been done here is, look, u is f of x. So the derivative of u with respect to x is going to be f derivative at x dx. And here dv is considered to be e to the power of minus x dx. So directly integrate both sides. v is obtained to be negative e to the power of minus x. So using integration by part, the integral of e to the power of minus x f of x dx is going to be the integral of u dv, and the integral of u dv is uv times minus integral of v du. So your u is basically f of x, and your v is the negative of e to the power of minus x. That's why we are having minus here. Since the integration is definite integral, evaluation is done from 0 to 2, so again 0 to 2, minus, actually it was minus, but due to the fact that this is negative, this minus turns to plus, then v du is going to come, e to the power of minus x comes directly here, and du is f derivative at x dx. Now try to observe what has been written here with the expression you obtained here. So students, if you try to move this expression to the left, you see you will have this expression as you see. That is the integral from 0 to 2 is a power of minus x f of x dx minus, because if you move this one to the left, you will get this to be minus, then this is going to come as it is. Now students, we are having here e to the power of minus x, e to the power of minus x being written twice, so we can take e to the power of minus x as a common out, and then f of x minus f derivative at x dx is going to remain, as you see here, you see. Therefore this is going to be written as can be shown. Then this is going to be equivalent to 2. Now this is a question we are having at hand. Now substitute 2 and 0 one after the other. So when you put 2 here, take the negative sign out, and then f of 2 is a power of minus 2 follows, minus, when you put 0 there, f of 0 is a power of minus 0 can come. You know that is a power of negative 1 times 0 makes 1, because is a power of 0 can come in, that is 1. 1 times f of 0 is going to come. But we knew what f of 2 is because it's already given, 3e squared. And we know what f of 0 is because it's already minus 5. So what is f of 2? It is 3e squared. So 3e squared times e to the power of minus 2 can come. And the bases are the same, so as you are adding the exponents, 2 plus minus 2, 0. E to the power of 0 is 1. And then you can obtain 3 here, students, 3. Right? So negative comes here, 3 follows, minus. F of 0 is already known, it's minus 5, it's given. So minus of minus 5 can come. So 3 minus minus 5 makes 8, but we do have negative outside, so it would be a negative 8. So you need to put negative 8 here in your blank space. And next from this, we have question number 3, and it's about a vector space. You have been asked to identify whether this statement is true or false. The set of integers is a vector space over the set of rational numbers under the operation of addition and multiplication says. So the given vector space here is, the given set here is a set of integer. So this set of integer is going to be evaluated whether it is a vector space over a certain field. The field given here is a rational number. So scalar numbers are going to be taken from these rational numbers, whereas vectors are going to be taken from integers. So as you know, dear students, for the discussion of vector space, you must have these two operations, and these two operations are addition and multiplication. They are already specified here. So there are actually 10 different criteria in order to say that a given set of elements to be called a vector space over a given set of field. So let's now check whether this fails in one of these 10, because instead of showing all these 10, let you come to guess at a situation where this may not be a vector space. So because falsifying the given sentence by taking one simple example is better compared to showing this is a given one by considering the given one as a vector space by considering those 10 criteria. So the solution goes like this. Now let you take to be 4. Students, now 4 is an integer. You see, 4 is an integer. I just take 4 from the sets of integer here. And let me take a scalar number alpha from the set of rational number. Like 1 over 3 is taken from rational number. So if you remember, students, the product of these two must exist in the set of integer. This is one property of vector space. But if you take the product of the 2 alpha times u, it will be 4 over 3. 4 times 1 over 3 is 4 over 3. Now actually we are having 10 different criteria, but I just took only one here. 4 over 3 never lies in the set of 4 over 3 is not an element of integer, right? And because of this, for being 4 over 3 not integer, you see, we can automatically say that the set of integer is not a vector space because it fails satisfying, one of those 10 conditions, right? So our conclusion is going to be the set of integer is not a vector space over the set of rational numbers. So what we need to write in your fill in the blank part is false, because you have been asked to write either true or false. That is it. So when you go to the next question, that is question number 4, you have been given that the limit of x plus k over x minus 5 to the power of 2x as x going to infinity is a power of 36. For k an element of real number. The question is, what is the value of k? So here what you need to do is you need to recall the important limit theorem, and that is limit of 1 plus 1 over x the power of x as x going to infinity is e, right? So you need to recall that. So basically these two are identical. If the limit as x going to infinity of x plus k over x minus 5 the power of 2x, this one is repeated simply. But we can now divide this as you see, now x plus k over x minus 5. Now multiply this by 1 over x, again multiply this by 1 over x. So 1 over x times x makes 1, and this is k over x, the power of 2x, and this is 1, was you are multiplying this by 1 over x again. You do have 1 here, and here minus 5 over x can follow. Since this 2x is common 1, I do have 2x for each of these two. Now, as you remember from the property of such kind of limit, if you are having here c, it will be the limit of this will be e to the power of c, right? But now we are having k here, so this will be e to the power of k. The limit of this is e to the power of k for x. Since you are having 2 here, it will be e to the power of 2k. You see, e to the power of 2k. Had you not have this number 2, this would have been e to the power of k alone. But because of this squared, you see, you need to have 2 here, e to the power of 2k. In the case of this again, e to the power of, what is this? This is negative 5. So e to the power of minus 5 can come. Since again this is squared, we need to have a number 2 here. So in order to understand this, recall that the limit as x going to infinity of 1 plus c over x, the power of x makes e to the power of c, students. Now here e to the power of k comes. But due to the presence of number 2, e to the power of 2k can follow. Had this been, for instance, 3, this would have been e to the power of 3k. this depends, the coefficient of k depends the coefficient on the coefficient of x. So here again, look, here is a power of minus 5 comes, but since we are having number 2, so square root follows. So this makes the following one. Look, is a power of 2k, negative 5 times 2 is negative 10. So when the bases are the same, so you will take one base e here, and then 2k minus 10, which actually is 2k plus 10. You have been told that this is equivalent to e to the power of 36, so have e to the power of 36 here, so the bases are identical, so you have to equate the exponents to have identical output. So 2k plus 10 is going to be equivalent to 36. So look here, students, now move 10 to the right, and then from this k is obtained to be 13, because 26 is going to come, and 26 divided by 2 is obviously 13, so it is when k is 13 that this limit is going to be e to the power of 36, right? I hope you have understood it. Okay, dear students, now we are in question number 5. So here you are asked to find the slope of the tangent line to this curve at the point 0, 1. So in order to determine the slope, what you need to do is you have to look for dy over dx here, because slope by definition is change in y over change in x. Because of this, we need to undergo implicit differentiation here. So this question number 5 requires the concept of implicit differentiation, the one you studied in your classroom. So now what is going to come as a solution is the following one. So you need to undergo derivative both sides. So as you are applying d by dx both sides, you are having this expression. As you see, d by dx of the left expression is equal to d by dx of the right one. So for this you need to use product rule, and the derivative of x with respect to x is 1, so 1 times e to the power of y is going to come, and then plus is used. X as a multiplier is used again, and the derivative of e to the power of y with respect to x is going to be e to the power of y dy over dx. You do the same for these two, but as you are coming to this side, the derivative of a constant 1 is 0, so clearly this goes to 0. So this is going to be like this. Look, the derivative for the first term, this one, x times e to the power of y, is going to be the expression inside this bracket. So the derivative of this with respect to x is 1, and 1 times e to the power of y is e to the power of y, then you do have plus. Now you will take x as it is, then it is e to the power of y's turn to be derivated. So the derivative of e to the power of y with respect to x is going to be e to the power of y itself, but you need to have dy over dx here, because the derivative is with respect to x on y, so you need to have dy over dx. Then because of this plus sign, you're having plus here, then you need to derive again this by using some rule of derivative. So again, applying product rule for this, you do have to see such expression. So as you are deriving this with respect to y, with respect to x, it will be dy over dx, so the multiplier e to the power of x comes as it is. Then plus comes because of this derivative rule. Then as you are deriving e to the power of x with respect to x, as you know, the derivative is itself e to the power of x, but you will take y as it is as a multiplier. So everything is available now. This is 0 because the derivative of a constant 1 is 0. My dear student, that our intention is to determine the slope, so we are interested to know what dy over dx is going to be. So let's collect like terms together here. I'm having dy over dx here, dy over dx here, so I may take dy over dx as a common out, and then take x e to the power of y plus e to the power of x as a multiplier. And I can move this e to the power of y to the right, and turns to be negative e to the power of y. And I can also move y e to the power of x to the right, and it's going to be negative y e to the power of x. So both are going to be negatives. So in doing this, I can have this one, dy by dx, the slope I'm talking about comes here, change in y over change in x, and this is negative of y e to the power of x plus e to the power of y divided by log x e to the power of y plus e to the power of x. Now look, we are interested to know the slope at a certain particular point, and the point here is at 0, 1. So in order to know the slope, you need to substitute 0 in place of x here, and 1 in place of y here. So in doing so, you can obtain slope at 0, 1 as you see. Look, when you put 0 here in x is a power of 0 makes 1, and 1 times 1 is 1. And here y is what, students? 1 again. So this is going to be e, right? It will be e. So this is going to be again x times e is a power of y, and again this is going to be like this. Your x is 0, so 0 times this is 0, so 0 is going to come, plus e is a power of 0 is 1. So what we need to adjust here is, look here, your y is 1, so e is a power of 1 is going to be e, right? So dear students, now you see you can obtain the final answer to be -1 minus e. Therefore, the slope at this particular point, at the point 0, 1, is going to be -1 minus e. That is good. Now proceeding to the next one, we have another question, and that is question number 6, and that is about the derivative question. You are given that if derivative at a is 10, then the question is to know what is the limit of f of a plus 3h minus f of a over h as h approaching to 0. So basically, this can be done as follows. We know that the derivative of a function at a is defined as the limit of f of a plus h minus f of a over h as h approaching to 0. This basically is a definition for a derivative directly taken from the definition. And we have been told that this derivative is 10. Here it is, a given information. Now, next from this, in order to come to this one, let's assign x to be 3h, students. Here we are having 3h. What we were having here was h, but now it is 3h. So let's make this to be x. Let x be 3h. And from this, h is going to be 1/3 of x, matter of dividing the whole by 3. So as h approaches to 0, look, as h runs to be 0, 3 times 0 is 0, so x again runs to be 0. So the question we are having here, the limit of f of a plus 3h minus f of a over h as h approaching to 0 is going to be like this. The limit of f of a plus, look, in place of 3h we are having x minus f of a, again in place of h we are having 1 over 3x. So students, from this you can move these 3 up and make 3 times the limit of f of a plus x minus f of a over x as x approaching to 0. Dear students, this is nothing but it is a derivative of f at a. The reason is it's a matter of changing, okay, the symbol here or the letter here. If you change this letter by any one, no problem. It can be what? It can be considered as the derivative of f at a. For example, you may take, okay, a letter k in place of h. You may have, for instance, a limit as k approaching to 0 of f of a plus k minus f of a over k. This is f derivative at a. So whatever variable you may use in place of h, it doesn't what? It doesn't make your derivative definition different from the previous one. So now what has been used in place of h here is x. So if you use x throughout, the limit as x approaching to 0 of f of a plus x, look here, this one, minus f of a over x can come. And this represents nothing but it is f derivative at a. It's a matter of changing h by x, nothing else. Okay? So this is going to be 3 times f derivative at a. But we knew what f derivative at a is. It's already given. It has been said 10. So this is going to be 3 times 10. And finally, 30 can come. So students, you are supposed to write 30 there in your blank space. Next from this, question number 7 is going to come, and here we are going to answer a question involving continuity. So this function, as a piecewise function, it has been defined this way. You've been told that this function is sine x over x for any value except 0. Except 0, the function is sine x over x. And for this particular case, the function is 2m plus 7 when x is 0. So you are asked to determine the value of m for which this can be continuous at 0. So dear students, this function is continuous everywhere, as you see, except 0, because it is broken at 0. It has been said that the function is sin x over x for any value except 0, and when it is 0, it is 2m plus 7. So we have to create a case of amendment for this function to be continuous at number 0. So to do that, what we need to do is we need to recall the definition for continuity. So the solution goes like this. A function f is said to be continuous at 0 if the limit of f of x as x approaching to 0 is the same as f at 0. So if this is so, the limit of f of x as x approaching to 0 from the right is the same as the limit of sin x over x as x approaching to 0 from the right. Mind you that approaching 0 from the right is nothing but using numbers like 0.1, 0.01, something like that. Numbers close to 0 but greater than 0. So during this case, your function is the upper one, sin x over x, because when x is different from 0, that is to say when you are approaching to 0 doesn't mean that when x is 0, right? So you are using numbers close to 0. So you see the upper one is going to be used, sin x over x. The lower one is used only when x is 0. Since x is approaching to 0, it doesn't mean that x is 0. So the function is sin x over x. So sin x over x equals 1 is going to come. Sin x over x is going to come, and we knew that this is 1, so this result is number 1. But as I said here, you see, this has to be the same with f at 0. But we knew that f at 0 is 2m plus 7. Here you have. So necessarily, in order to know what m is, you have to take this equation, that is 2m plus 7 equals 1. So moving 7 to the right, it will be 2m equals minus 6. And from this, m is going to be minus 3. So the value of m is going to be negative 3. So you need to put negative 3 in place of your blank space. So having this into account, what comes next is question number 8. Given that f of x is the integral of cos 2t plus t squared dt from x cubed to x, then you are asked to find f derivative at 0. So dear students, in order to answer this one, you need to go back and you need to read about fundamental theorem of calculus 2. So read that and apply the concept in order to answer this one. So the solution goes like this. Using fundamental theorem of calculus, you see that if f of x is given by this, the derivative of this can easily be obtained by using this. F derivative at x is going to be, look, as you are derivating this, derivative and integration are anti to each other, so one can cancel the other. So the integrand expression is going to come as it is. But you need to know that. You see, we are going to substitute x and x cubed one after the other, taking minus into account, okay? And you need to know also that chain rule must be used. After substituting x, we need to carry out the derivative with respect to x. And later, after substituting x cubed in place of t, we need to carry out derivative with respect to x on x cubed. So f derivative at x is going to be like cos the integrand. Take the integrand as it is without any sort of confusion. So cos is going to come as it is, but in place of t now, take x. 2x plus x squared, you see? Then we have to derivate the upper one with respect to x, and that is d by dx of x. Basically, it is 1. Then minus comes, because of the fundamental theorem of calculus. Then again, for this case, you need to take again cos as it is, but in place of t now, it is x cubed to be used. So cos 2x cubed plus, now here in place of t again, I'm going to use x cubed. So x cubed, the power of 2 makes x the power of 6. You see? Then since I'm substituting x cubed in place of t using chain rule, I need to derive x cubed as you used derivating with respect to x before. So this is going to be d by dx of x cubed. So from this, what can be obtained is the following one. So if derivative at x is going to be cosine of 2x plus x squared, so the d by dx of x is 1, and minus what is going to come next from this is this. If derivative at x is equal to cosine of 2x plus x squared minus cosine of 2x cubed plus x to the power of 6 times 3x squared, because the derivative of x cubed is 3x squared. Now everything is done. Okay, so what we are asked here is to determine the derivative of f at 0. So from this, f derivative at 0 is going to be, put 0 in place of x, cosine of 2 times 0 plus 0 squared minus cosine of 2 times 0 cubed plus 0 to the power of 6, 3 times 0 squared. So look here, since this one is 0, the whole goes to 0, because 0 times this is going to be 0, but here 2 times 0 is 0, plus 0, 0, cos 0 can come. So f derivative at 0 equals cos 0 can come, but we know that cosine 0 is 1, so the answer is going to be 1. I hope you have understood it. Okay, dear students, now let's see how we can also solve question number 1 of this workout part. The question says, show that the set containing 1, x, and x plus x squared is a basis of a vector space over the set of polynomial functions with degree less than or equal to 2 under the operations of addition and multiplication of the field of set of real numbers. So we are now going to see how we can show this W as a base of the vector space of the given set. So let's proceed. So as you know, the set given here is non-empty because as you see there are 3 elements here, so it is non-empty, and it is also a subset of polynomial functions with degree less than or equal to 2, because if you see all the elements here, you see their degrees are less than or equal to 2. Now let's assure the following 2 conditions in order to show the betas. One is the case of linear independentness, and the second one is a case of a spanning condition. So let's now see how these elements are linearly independent. So let's take arbitrary 3 scalar numbers or real numbers a, b, and c. Now let's try to write these functions as a linear combinations. So we directly multiply 1 by a, and b by x, and c by x plus x squared. And let's equate this with 0 function 0 here. Now here, if we are able to obtain at least one non-zero value for a, b, and c, we can say that these 3 functions are linearly independent. But if we are unable to obtain such non-zero value so that this can be true, you see this set is considered to be made of linearly independent elements. So let's see how we can do that. So as you see, a times 1 makes a, and b times x makes bx, c times x is cx, and then cx squared equals 0 can come. So in order to have 0 here, necessarily the coefficient of x squared and the coefficient of x as well as the constant must be 0. So directly we can have the constant a here 0, and here the coefficient of x is b plus c, and this b plus c must be 0 because the coefficient of x to the right side is 0, and here also the coefficient of x squared, which actually is c, must be 0 because we don't have here x squared, so it is accepted as the coefficient is 0 for the right side. So c is 0. So if a is 0 and c is 0, clearly b plus c is 0. C is once 0, b goes to 0. So as you see, this happens if and only if a is 0, b is 0, as well as c is 0. This shows you that this set is made of linearly independent functions, and because of this we can understand that W is a set of linear independent elements. But this by itself is not enough. We have to show again the spanning condition of this set. That is to say that for any arbitrary element from the given one, from a polynomial function with degree less than or equal to 2, let's see how the element can be formed by the linear combination of these three elements. Okay, so this set must generate any function whose degree less than or equal to 2. And because of this, let's have again, let's check the spanning condition and take an arbitrary quadratic expression, ax squared plus bx plus c, where capital A, B, and C are real numbers. Now take arbitrary scalar numbers A, B, and C. So our intention is to construct or to generate this quadratic equation from the given set using these scalar numbers. So let's now rewrite the combination of these scalar numbers with the given elements of W. So as you see, or as you saw before, this is A times 1 plus B times x plus c into x plus x squared. This must make ax squared plus bx plus c. Now we are checking whether the given quadratic expression or a degree 1 expression, because in case A is 0 it will be a linear one, and if A and B are 0 you can have a certain degree 0 expression, and if C is 0, A and B are also 0, we can have a 0 function. So our intention here is whether this set of elements can make this quadratic equation or not. We are going to check that one. So here we are having A times 1 B times x plus c into x plus x squared. So our intention here is to write A, B, C. This is small letters A, B, C in terms of these capital letters A, B, and C, because this is a quadratic expression. We took one element from the vector space. Now we are running to see how this vector space element can be generated by these three elements of W. So let's proceed now. This, after simplification, we can have A plus B plus cx squared is equal to x squared plus bx plus c, because as you see B and C, we can have bx plus cx, so you may take B plus c as a common one, and then x is taken out, so we are having now this. So for this, C must be A, B plus C must be B, and this small letter A must be C. So clearly A is C, and B plus C must be B, and C must be A. So please try to know that this is a capital letter C. Now from this we can understand that A is C, small letter A is A, and B is B minus A, and C is A. So as we are having here, C is A, as you see. Since C is A, look, we are having A here, so small letter A is again capital A, and B is nothing but it is B minus C, but we know what C is, it is A, so it will be B minus A. Now we have written these small letters A, B, C in terms of capital letters, as you see. A, B minus A, and A. For example, if you are having a certain quadratic equation made of 2x squared 3x plus 4, having A2, B3, and C4, capital C4, then these values A, B, C, small letters A, B, C, can be known from this, you see. So as we said, we took A to be number 2, so A, you can take small letter A to be 2, and small letter B is going to be 3 minus 2, and this is going to be 2 again. So in such a way, you see, the quadratic equation you took can be generated by this set of elements. So this shows you that, you see, this set can generate any function whose degree is less than or equal to 2. Because of this, we can say that this set which is called W is a basis for the given vector space. I hope you have understood. Now coming to the next one, we have question number 2 for the workout part. So you are asked to find the limit of this one. So in order to find the limit of this, let me call this to be y. Y is equal to 3 is the power of x plus 4 is the power of x, the power of 1 over x. And from this, let me introduce ln both sides because we are having an exponent 1 over x. So ln y is equal to ln of 3 is the power of x plus 4 is the power of x, the power of 1 over x. So using the logarithm property, this 1 over x can come in front. And then we can have ln y is equal to ln of 3 is the power of x plus 4 is the power of x over x. Now let's have this limit. As you see, the limit of ln y as x goes to infinity is the same as the limit of the expression here as x goes to infinity, but students know that as x goes to infinity, 3 is the power of x plus 4 is the power of x. This goes to infinity, and ln of this large number again goes to infinity. Again, we are having here infinity because x is running to be infinity. So this sort of limit is indeterminate type of infinity over infinity. So we can have now L'Hopital's rule for this, as you studied before. So applying L'Hopital's rule, you can obtain this to be like this. So the limit of ln y as x goes to infinity is equal to the limit of ln of 3 is the power of x plus 4 is the power of x over x. Now just apply L'Hopital's rule, try to derivate the upper one. So the derivative of ln of 3 is the power of x plus 4 is the power of x is 3 is the power of x ln 3 plus 4 is the power of x ln 4. 1 over 3 is the power of x plus 4 is the power of x, and when you derivate the inner one, you will get the upper, the numerator expression. And as you are derivating x, it will be 1, so you will never see 1 here, but it is there. Now as x goes to infinity can come. Now in order to evaluate this in a better sense, let's multiply the numerator and the denominator by 1 over 4 is the power of x, because that one is the larger exponential expression compared to 3 is the power of x. So try to multiply the numerator as well as the denominator by 1 over 4 is the power of x. So you can have this condition, and as you are doing this, look, you can have this one, 3 is the power of x over 4 is the power of x. You can write as like this, and ln 3 comes here. Now look here, 4 is the power of x can be cancelled by 4 is the power of x, ln 4 can come, and here again 1 over 4 is the power of x can cancel this one, and you do have 1 here, and then 3 over 4x. Now look, as x goes to infinity, this approaches to 0, 0 times ln 3 is 0, then ln 4 can come, and again as x goes to infinity, this goes to 0, 0 plus 1 is 1. So finally you will obtain this to be ln 4. This is not the answer actually. We are interested to find the limit of y, not ln y, right? So there should be a mechanism of writing y from ln y, and for that you need to recall this. Y is a power of ln y, as you know, and from this you can have now limit. The limit of the question we are having now turns to be the limit of y as x goes to infinity, because we have said that this is y, and this is going to be the same as e the power of limit of ln y as x goes to infinity, because e the power of ln y is y, and this is e the power of, now we have determined this limit over here, it is obtained to be ln 4. So e the power of ln 4 and e the power of ln 4 makes 4. So the answer for this is going to be number 4. And next from this we have the other question, and question number 3, you are asked to find the interval of n for which this improper integral can be convergent and divergent. This can be done in the following manner. This is the integral from 1 to infinity of 1 over x to the power of n dx. This is equivalent to this one, just making x to the power of n up. And from this, limit can undergo as b goes to infinity, because in place of this infinity we can have b here. So using power rule, this is going to be the limit of x to the power of 1 minus n. You simply add 1 here on the exponent, and 1 minus 1 from 1 to b, and now substitute b and 1 by 1 in place of x. As you see, this is going to be the limit of, put b in x, b the power of 1 minus n, minus, put 1 in x, 1 the power of n expression is 1, so we are right, minus 1 over 1 minus n. So you can take 1 over n minus 1 as a common out because analysis is done on B. So look, 1 over n minus 1 is taken out, and then the limit of minus 1 as b goes to infinity is minus 1. So we are having now plus of limit of b the power of 1 minus n. So for this to be convergent, necessarily 1 minus n should be, as you see, less than 0, because it converges to 0 if this is negative. So if 1 minus n is less than 0, that is to say n greater than 1, or 1 to infinity, the improper integral is going to be convergent. Otherwise, if for instance you are having 1 minus 1, 1 minus n to be positive or equal to 0, it will be divergent. The reason is, you see, if 1 minus n is positive, if this is positive, b is positive, the power of positive goes to infinity, and because of this sake, the series is the improper integral will be divergent. Hence the intervals are this. Okay, now students, let's do question number 4, and this is going to be the last question of the workout part. So as usual, just you need to subscribe to this channel because it's very important for you. So directly going to the question, you are asked to find the critical number, interval of increasing and decreasing, relative extreme values if any, and also interval of concave up and down, and inflection point for this particular rational function. So in order to find all this, the primary thing that you need to do is you have to find the first derivative of this function first, and for this you need to apply quotient rule because it is a rational expression. So recalling that, let's see how we can find the critical number. So here it is. Your function f of x is 2x squared over x squared minus 1. So you are having a numerator 2x squared and the denominator x squared minus 1. So the derivative of this is going to be, first derivative the numerator, it will be 4x, as you see, because 2 comes down and it multiples 2, it will be 4x, and you will take x squared minus 1 as it is. Then using quotient rule, you do have a minus there, and then you will take 2x squared as it is, and you derivate x squared minus 1. The derivative of x squared minus 1 is 2x again, as you see. Then you need to square the denominator, x squared minus 1 the whole squared. This is basically done using quotient rule. And the next one is simplifying this. So 4x times x squared makes 4x cubed, and 4x minus 1 makes 4x, and this makes minus 4x cubed divided by x squared minus 1 the whole squared. Here there are terms to be cancelled. 4x cubed can be cancelled by minus 4x cubed, and then you are going to obtain negative 4x divided by x squared minus 1 the whole squared. Look, 4x cubed can be cancelled by 4x cubed, and then you can have minus 4x over x squared minus 1 the whole squared. So the first derivative is now obtained. Now from this you can determine the critical number. The critical number, as you know, is a number in the domain of the function that makes your first derivative 0 or the first derivative doesn't exist. So in the case of this, the derivative gets 0 when 4x comes 0, when the numerator comes 0 here. So dividing the whole by negative 4 or 4, you will get x to be 0. So here 0 is an element of the domain of the function, because as you see, the domain of the function is the set of all real numbers except minus 1 and 1. So 0 belongs to the domain, so it is a critical number. So the only critical number we have here is 0. So look here, 1 and the minus 1, even though 1 and the minus 1 never define the derivative, they cannot be considered as the critical numbers because 1 and minus 1 are not part of the domain. At the beginning they are excluded. So the only critical number we are having here is 0. Now proceeding to B, you are asked to find the interval of increasing and decreasing condition. So as you know, the interval of increasing happens on the interval containing x where the derivative is going to be positive. So we already have done the first derivative as you saw before. Look, this is the first derivative result. The denominator is always positive because it's the square of a certain expression. So in order to have a positive output, because the first derivative must be positive, this negative 4x must be positive, okay? Positive divided by positive, we can have a positive value. So minus 4x must be positive. For that, negative 4x must be greater than 0. And from this, since this one is negative, when you multiply the whole by negative, the greater than sign will automatically change to less than 1. And dividing the whole by 4, you see you can have x to be less than 0. So the interval of increasing is from minus infinity up to minus 1, union from minus 1 to 0. Basically it was less than 0, but we have to create a means of rejecting minus 1 because minus 1 is not part of the domain here. And because of that, you see the interval of increasing is going to be this one. And when we directly go to interval of decreasing, we must have the case where the first derivative is going to be less than 0. And we directly come to this again because it's already done. The denominator is always positive, but our intention is to have a negative output because this must be less than 0. Negative must exist here. So in order to have negative here, since the denominator is positive, negative 4x must be negative. So negative 4x must be less than 0. So dividing the whole by negative 4, the inequality less than automatically changes to greater than sign. So x greater than 0 can come. So the interval of decreasing is going to be from 0 onward. But here again 1 must be rejected because 1 is not part of the domain. And because of that, 0, 1, union 1 to infinity is going to be the interval of decreasing condition. Now next from this we have relative extreme values, and the relative extreme values are nothing but those relative maximum and the relative minimum. So as you know, when you are having a shift from positive to negative around the critical number, you are going to have a relative maximum value, and from negative to positive shift at a certain critical number, you do have a local or relative minimum value. So here the case, minus 4x is here, and x squared minus 1 the whole squared is here. Your first derivative is also written here. So minus 4x gets 0 when x is 0. X squared minus 1 the whole square gets 0 when x is either minus 1 or positive 1. So as you see, minus 4x is going to be positive because you are going to use negative values from 0 to the left. So in the case of this, you do have positive values. But in the case of this, from 0 to infinity, you are using positive numbers in place of x, and hence you do have negative outputs. But for this, we always have positive values except at minus 1 and 1. So as you are dividing these two, you do have positive, negative divided by positive, negative divided by positive, negative values. Now we need to see the case where we can have the change of the signs around the critical number. The only critical number we are having here is 0, and at 0, as you see, sign is changing from positive to negative. So this shows you that there is a relative maximum value at 0. And we don't have a change from negative to positive. Because of this, we don't have any sort of local minimum value for this particular function. The sign changed from negative to positive at nowhere. Because of this, there is no local maximum value. And again, the sign changed from positive to negative at 0. As I said, at 0, at the critical number, the derivative changed from positive to negative. Because of this f at 0, your function was f of x to x squared over x squared minus 1. So f at 0 is going to be 0, right? So 0 is going to be our minimum value, right? 0 is our minimum value, our maximum value, sorry. So please try to have a certain correction here, make this to be minimum, right? It has been said here maximum, so please try to change this maximum one to minimum one, okay? Because here is our concern from negative to positive. In the case of this, we don't have any local minimum value, so make this to be minimum, and this one is right. So 0 is the local maximum one. Please have this correction. So f at 0, which actually 0 is our local maximum value, and we don't have any local minimum value. So far so good. Now comes the case of D, and that is the interval of concave up and concave down. And this is basically obtained by carrying out second derivative of the function. And we knew that the first derivative is this, so again applying quotient rule, the second derivative can be obtained. So as you are applying this second derivative using quotient rule, again the derivative of minus 4x is negative 4. And you will take this as it is, x squared minus 1 the whole squared. Now derivate the denominator, 2 comes down and 2x squared minus 1 can come, and when you derivate the inner one it will be 2x, and this negative 4x will be taken as it is as a multiplier, and then this must be squared, so as you are squaring this you do have x squared minus 1 the power of 4. And from this x squared minus 1 can be taken out as you see common and can be simplified by this. Then you do have x squared minus 1 cube. So as you are taking 1x squared minus 1 out, you will left with 1x squared minus 1 as you see, but this is already taken out. So minus 2 into 2x minus 4x can come. So this is minus 4x squared plus 4. You can simplify this one as you see, and this can come. Negative 4x squared can be cancelled by, here we are going to have negative 4x squared plus 4, and this is minus 2 times 2 is minus 4, with minus 4 positive 16. So 16x squared minus 4x squared makes positive 12x squared, and this negative 4 multiplied with negative 1 makes positive 4. So you will have this one. So now we need to identify the case where this second derivative is going to be positive and negative. So the interval of concave up is obtained when the second derivative is positive, and clearly the numerator is always positive as you see. So we need to concentrate on the denominator alone, and as you know, x squared minus 1 comes positive if you are taking x values greater than 1 and less than minus 1. So clearly the graph of the function gets concave up within this interval, and when you come to the interval of concavity down, again the second derivative must be less than 0, and as I said, the numerator is always positive, and when you come to the denominator, your intention is to have the second derivative to be negative value. So this is attained when you are taking x values between minus 1 and 1, because as you are taking values between minus 1 and 1, the denominator is going to be negative. So negative numbers, the power of 3 is negative. In the numerator you are having positive divided by negative gets negative, so the interval of concave down will be from minus 1 up to 1. So what comes next is the inflection point, and the inflection point is a transition point from concave up to concave down and vice versa, and this is attained when the second derivative is going to be 0. So as we calculate, this is a case where the second derivative is going to be 0. What is going to come is the following one. Look, the second derivative is this one, 4 plus 12x squared into x squared minus 1 cube, and this gets 0 when the numerator is getting 0, but this can't happen because 4 plus 12x squared is always positive, whatever value you may take. As long as you are in the real number system, you see you are unable to obtain x value that can make this 0. And because of this, we do not have this inflection point.